Okay, we are going to get started here, and we are going to get through most of 8.5. There will still be some stuff we'll have to wrap up on it on Friday before we do the next section, but the next section isn't near as long as 8.5, so we should be able to wrap it all up on Friday. Okay, so remember 8.5 is talking about rational functions. Okay, rational functions are functions that are fractions that have x's sometimes in the top and the bottom. Okay, so let's talk about some distinguishing features of these rational functions, and a lot of them we talked about. The domain, remember, the domain is the x values that are included in your function. So what we want to do is find the zeros of the denominator to exclude from the domain, right? So the domain comes from finding the zeros of the denominator and then excluding those values from the domain. We also talked about asymptotes. We talked about vertical asymptotes. We talked about horizontal asymptotes. And what did those give us? Those gave us, vertical asymptotes gave us those kind of invisible lines that would be going through the graph that our graph did not touch. Okay? The horizontal asymptotes, same type of thing. How did we find the vertical asymptotes? The vertical asymptotes were also kind of like you found the domain. So also the zeros of the denominator, as long as they weren't also zeros of the numerator. And vertical asymptotes always come in the form of the equation x equals wherever your vertical asymptote ended up being. The horizontal asymptotes came from that. It's kind of like a chart. And it has to do with the degree of the numerator compared with the degree of the denominator. If the degree of the numerator was less than the degree of the denominator, then the horizontal asymptote would always be at y equals 0. If the degree, and what is the degree? The degree is whatever the highest exponent is. So if the degree of your numerator was greater than the degree of your denominator, then there was no horizontal asymptote. And then the last situation was if your degrees equaled each other, then your horizontal asymptote was at y equals, then you would look at the leading coefficient of the numerator and the denominator. For instance, if your function was this, oh, be nice if you could see it. If this was your function and your degrees were equal, they were both 2, that means your leading coefficients would be what your y equals would be. So this one would be at y equals, that's where your horizontal asymptote would be, which would be the leading coefficient of the top over the leading coefficient of the bottom. So those are your 3 options for horizontal asymptotes. The other 2 distinguishing aspects that we're going to talk about are the x-intercepts of your rational function and your y-intercept of your rational function. So the x-intercept is going to come from the zeros of the numerator as long as they are not zeros denominator. So that's where your x-intercepts are going to come from, the zeros of the numerator of your rational function, as long as they are not also zeros of the denominator. The reason that the zeros of the denominator exclude those zeros in the top is because if you're a zero of the denominator, that means you're not in the domain of the function. You cannot be part of the graph, right? Those numbers are excluded from the graph of the function. Well, if you're excluded from the graph of the function, then you can't be part of the graph. You can't be an x-intercept. So that's why only the numerator is zeros as long as they're not also zeros of the denominator. The last thing that we're going to talk about is the y-intercept. And the y-intercept comes from replacing all the x's in the problem, in the function, with zeros. Once you replace all the x's in the function with zeros, your y-intercept is whatever is left over. If you replace all the x's in the function with zeros, and it turns your denominator into 0, then that would just mean there is no y-intercept in the graph. So if So when you replace all the x's with zeros, and that just happens to turn your denominator into a 0, then that just means there is no y-intercept, right? Because you can't have your denominator be 0. So these domain, vertical asymptotes, horizontal asymptotes, x-intercepts, and y-intercepts are going to be some distinguishing features of these rational functions. So we're going to find these things and then sketch them to help us determine what this graph would look like. To choose, these are all multiple choice problems, but knowing these features are going to help us choose which problem matches the function that is given. Okay, so we didn't do number 3 on Monday, so we're going to start with that one and then go to number 14, which is where we would start with the other ones. So on number 3, the function that is given to us is f of x equals 3 over x squared minus 49. So on this one, I am going to find all of the things that we just talked about. So before I start listing all those out, the domain, the vertical and horizontal asymptotes, the x and y intercepts, I'm going to just list out the zeros of the numerator and the zeros of the denominator. So if there is no x in your numerator, then there is nothing that would make it 0, right? Nothing is going to turn the numerator into 0. So there is no zeros of your numerator. The denominator, so let's see, this one's going to have 2 zeros, right? Since it's x squared. Also, since it's x squared, I can go to my quad program to find the zeros. Be careful when you type in your A, B, and C. If this is the option, if this is the method that you're choosing, your A is the number in front of x squared, which in this case would be 1. Your B is always the number in front of x. Look here, there is no x, which means you would use 0 as your B. C is your constant, which is negative 49. So if you punch that into your quad program, what is it going to tell you? Your zeros are negative 7 and positive 7. If you don't have the quad program, you would have to factor this. It's a difference of perfect squares method of factoring. So to get x squared, you would need x and x. Factors that are the same that multiply to 49 would be 7 and 7. Your signs when you are factoring difference of squares are always positive and negative. If you set these two factors equal to 0 and solve them for x by subtracting 7s here to get x equals negative 7, adding 7s on both sides there to get x equals positive 7. So that's how you would get the zeros of that denominator if you didn't have the quad program. So let's talk about the X-intercept and the Y-intercept. Or no, excuse me. Let's talk. So now that we have found the zeros, let's find, it doesn't ask us to find the domain on that one. So we'll hold off on that. It does ask me to find the vertical asymptote, horizontal asymptote. It doesn't ask me to find the X or Y intercept, but it's going to be necessary to be able to determine this graph. So what does the vertical asymptote come from? Remember what I just read on the board. The vertical asymptotes come from zeros of your denominator that are not also zeros of your numerator. Okay, so since the numerator doesn't have any zeros, I don't have to worry about that on this one. So my two vertical asymptotes are going to be at x equals 7 and x equals negative 7. My horizontal asymptote comes from the degree of the top compared to the degree of the bottom. What is the degree of the top? It is 0 because there is no x's. The bottom is an x squared, so that means the degree of the denominator, or let me say it back the other way. The degree of the numerator is less than the degree of the denominator. What does that tell you about the horizontal asymptote? It is at y equals 0. So it doesn't ask me for anything else. I'm going to show you why it is beneficial to know how to find the X and Y intercepts. Because if I just sketch what I know here, okay, I'm going to do the hash marks like they do them in your multiple choice. The hash marks go by 2s, it looks like. Yeah. So 2, 4, 6, 8, 10, 12, 14. So they go by 2s. So I'm going to draw in these two vertical asymptotes. So let's see if my hash marks go by 2s and I need a vertical asymptote at x equals 7. So 2, 4, 6, and then right in between. So there's a vertical asymptote. And then also one at negative 7. So negative 2, negative 4, negative 6, and then halfway to the next one for negative 7. So there's a vertical asymptote. The horizontal asymptote is at y equals 0, which is actually just going straight through the x-axis right here. So that's all the information that it asked me to find on this problem. But if you are looking at your options, you'll notice that that only helps you say that it's not B or C. Because look at B and C. B and C each only have that one vertical asymptote, but A and D both have vertical asymptotes like we do at +7 and -7. They also, it's hard to see it, but they also both have horizontal asymptotes at y = 0. Y = 0. It's got a little dashed line there, which means the information that I have just right here does not tell me between A or D. So now I am going to find the Y-intercept to see if that'll help me. How do you find the Y-intercept? You replace all the x's in the graph with zeros. So I'll have 3 over 0 squared minus 49, which is 3 over 0 squared is 0 minus 49. So what does that give me? 3 over -49, which means my Y-intercept is somewhere, it's going to cross through the Y-axis just a little bit on the negative side. Now look at A and D. Look where A crosses, a little below the origin, but look where D crosses. You see how it's a little above the origin. So it's crossing the Y-axis in the positive side of the Y. So that's why you would narrow it down to the A graph. Okay? Now, we did the rest of those on Monday, so let's go to 14, and I think we'll get through all of them except maybe the last one. So again, on every single one of these problems, what I'm going to start off doing is finding the zeros of the numerator and the denominator, because that helps me with several parts of the problem. It helps me find the domain, right? The domain is the zeros of the denominator, excluded. It helps me find the vertical asymptotes, because the vertical asymptotes are the zeros of the denominator that are not also zeros of the numerator. It doesn't help me find the horizontal asymptotes because that goes with the degrees. But the X-intercepts, which I didn't have to find on this one, but that is the zeros of the numerator that aren't also zeros of the denominator. So this one didn't have any X-intercepts. So this right here, but if it did, they would have come from the zeros of that numerator. So it helps me find a good part of the answers to all of the questions it's going to ask me on each of these functions. All right, let's look at 14. The function is f of x equals 3x plus 3 over x. So let's see what our zeros are. Let's see the zero of the numerator. So to find the zeros, all you have to do is set this equal to 0. So 3x plus 3 equals 0. Solve it for x, which means subtract the 3 here. So 3x equals -3. Divide by 3. Get x equals -1, which means the zero of the numerator is -1. What is the zero of the denominator? Well, if you set its denominator equal to 0 and solve it, it's automatically solved, right? X is already by itself, so the zero of the denominator is 0. So there's your zeros. Okay, again, if you do that on the front end, it's just going to help you answer a lot of the different questions. Okay, now I'm going to erase this part where I did that solving just so I'll have my information organized. So we're going to find all the things. Let's see. We're going to find the domain, the X-intercept, the Y-intercept, and we're going to go ahead and find the vertical and horizontal asymptotes also. So where does the domain come from? The domain comes from finding your zeros of your denominator and then excluding that from your domain, which means 0 needs to be excluded from my domain. And it wants me to write that in interval notation, which means I want to show that I am including everything on the number line, all the real numbers on the number line except 0. So if I'm doing that, where does the number line start? All the way to the left. It starts at -infinity, and then I want to go all the way to 0, but I want to put a parenthesis around that 0 because that means do not include that number. And all the numbers above 0, so from 0 to positive infinity. So there's your domain. Now we'll do the X-intercept and the Y-intercept. Where does the X-intercept come from? Again, I can come up to where I found the zeros. The X-intercepts are the zeros of the numerator that are not also zeros of the denominator. So what's the 0 of the numerator? It is -1. Is that a 0 of the denominator? It is not, which means it's going to cross the x-axis at -1. Now, remember, the x-intercept is a physical point. All points come from ordered pairs that have x-coordinates and y-coordinates, which means the x-intercept, the x-coordinate will be your x-intercept. The y-coordinate at your x-intercept is always 0. That's what makes it cross the x there. So let's see, my x-intercept is at -1, 0. What about your y-intercept? How do you find that? You find that by replacing the x's in your function with zeros and seeing what you have left. So if I replace the x's with zeros, I'll have 3 times 0 plus 3 over 0. Look what happens to my denominator. Look at the top. 3 times 0 is nothing. Nothing plus 3 is 3. But what? My denominator is 0. What did we talk about if you replace the x's in your function with zeros and it turns your denominator into a 0? What does that tell you about your y-intercept? That there's not one. It does not cross the y-axis. There is no y-intercept. Now, it doesn't ask me in this specific problem to find the vertical and horizontal asymptotes, but it's going to be very helpful in determining what this graph looks like. Let's talk about the vertical asymptote first. Vertical asymptotes, remember, again, you can come up here and look at your zeros. Vertical asymptotes are x equals the zeros of your denominator that are not also zeros of your numerator. So that would be x equals 0. The horizontal asymptote comes from the degree comparison. Looking at these, degree of the numerator and the denominator are both 1, right? 1 is their highest exponents, which means y horizontal asymptote is going to be at y equals the top's leading coefficient over the bottom's leading coefficient, which is a 1. So y equals 3 is your horizontal asymptote. So let's sketch this out, what we know. Let's see, what did their hash marks go by this time? They go by 2s again. So 2, 4, 6, 8, 10, -2, 4, 6, 8, 10. So again, all those hash marks are 2s. So let's see. It's crossing the x-intercept at -1. So if this is -2, it's going to cross it right here. That's what's going to cross the x-axis. It's not going to cross the y-axis because there is no y-intercept. That's the only thing it asked me to find on this problem. That's not going to help me very much. These two things will, though. There's a vertical asymptote at x equals 0. Oh, what happened to my red marker? So x equals 0 is right here. There's a horizontal asymptote at y equals 3, +3. So again, if these are 2s, that's 2, that's 4. So right in between those is a horizontal asymptote. So let's see if that helps me. Let's look at A. What does A show? A horizontal asymptote at y equals 3. There's a dashed line on x equals 0. It crosses through the x-axis at -1. So it does all the things that my graph says that it needs to do. So that one is still a good option. Look at B. Look where B's horizontal asymptote is. It's down here at -3. So that's why it's not B. So that was a good thing to know. Look at this one. Horizontal asymptote at +3. So that's good. Vertical asymptote at 0. But look where it crosses the x-axis. It crosses over at +1. So that's why it wouldn't be D. And this one, look at the vertical asymptote. It has a vertical asymptote over there in the positive area, right? Not at 0. See that vertical asymptote, that dashed line that goes up and down? It's not at 0. If it was at 0, it will be right on the y-axis. So that's why you could narrow it down to A. All right, let's look at number 15. I'm going to do the same thing. I'm going to find the zeros of the numerator and the denominator because that helps me answer a lot of the questions. All right, let's find the zeros. Let's see, the 0 of the numerator means set x plus 3 equal to 0 and solve it. So I'll subtract 3 from both sides. So x equals -3. So the 0 of the numerator is -3. The denominator, again, that's a difference of squares, like we saw earlier. If I put that in my quad program, my A, B, and C, A is the number in front of x squared, so it will be 1. B is the number in front of x. Since there is no x, your B would be 0. And then C is your constant, which is -9. You put that in your quad program and solve it, you'll get -3 and +3 as your two zeros. If you had to factor it, what would this be factored? X plus 3 and x minus 3. That would also give you -3 and +3 as your zeros. So now that we have found the zeros of the numerator and denominator, let's look at all of our features. This one does ask everything. First, ask for the domain. Which again, I can just, now that I have found the zeros, I just use them where I need to use them. The domain needs to include all the numbers on the number line except -3 and +3. So where does the domain start? -infinity. It travels up the number line. Who's it going to run into first on the number line? It'll run into -3 first. So -infinity to -3 takes into account all the numbers below -3. Now I want to include the numbers between -3 and +3. So -3 and +3. So that it takes into account all those. Now, who do I have left to include? All the numbers above 3. So from 3 to infinity. So there's your domain. Then it wants to know what's next. X-intercepts and Y-intercepts. So where do the X-intercepts come from? Again, very beneficial that I have already found this because now I just need to use it. The X-intercepts are the zeros of the numerator that are not also zeros of the denominator. So what's the zero of the numerator? It's -3, but that is also a zero of the denominator, which means it's not an X-intercept. Why is that? Because look, -3 is not a point on the graph, right? It's excluded from the domain. It is not a point on the graph. That's why we are excluding it here and here. Well, if you're not a point on the graph, then you most certainly are not an X-intercept. So that's why, even though it's a zero in the numerator, since it's also a zero in the denominator, it is not an X-intercept. Oops. No X-intercept. The Y-intercepts comes from replacing all the X's in the function with zeros and seeing what you have left over. So let's see, up top I have 0 plus 3. In the bottom I have 0 squared minus 9. 0 plus 3 is 3. 0 minus 9 is -9. So if I simplify that, I get -1/3. Now remember, your Y-intercept is a point. All points come from ordered pairs. Since this is the Y-intercept, that means its X is 0, right? I put zeros in the X's. That's what told me the X is 0. It gave me -1/3 for the Y. So there's your Y-intercept. Now let's find the vertical and horizontal asymptotes. Vertical asymptotes, again, coming up to my zeros. The zeros of the denominator are -3 and +3. But remember, you're only a vertical asymptote if you are a zero of the denominator, but not a zero of the numerator. So which one of these is not a vertical asymptote? The -3. So only X equals +3 is a vertical asymptote. And the last feature is the horizontal asymptote, which comes from the degree comparison. So what's the degree of the top? It is 1. The degree of the bottom is 2, which means the degree of the numerator is less than the degree of the denominator, which tells me the horizontal asymptote is automatically Y equals 0. So let's sketch this, what we know. see, I'm sure they go by 2s again. Oh no, they go by 1s. So these hash marks are all 1s. So let's put our asymptotes up first. There's a vertical one at x equals 3, positive 3, which means vertical asymptote there. The horizontal asymptote is at y equals 0. So y equals 0 is actually the x-axis. So there's a horizontal asymptote there. Let's see, it's not going to cross the x-axis, and it is going to cross the y-axis at negative 1/3, which will be just below the origin. It's where it's going to cross the y-axis. So let's see how this helps me. What helps me, first of all, is looking at your vertical asymptotes. Two of those options, B and C, look what B and C both have. B and C both have vertical asymptotes at positive 3 and negative 3. So they are thinking that you thought there were vertical asymptotes at both of these places, but we knew there wasn't one at negative 3 since that was also a 0 in the numerator. And then look at A, the difference between A and D. A's vertical asymptote, oops, sorry, I'm trying not to make y'all sick, is at negative 3. A's vertical asymptote is at positive 3. So that's what distinguishes between A and D. You needed the vertical asymptote to be at positive 3, the horizontal asymptote to be at y equals 0. It needed to cross the y-axis. Look where it crosses the y here. A little bit down, right? So it crosses it at negative 1/3. And it doesn't cross the x-axis because look at your x-axis. Look what, when it almost gets to the x-axis, look what it puts in there. It puts in a little hole. That means it doesn't touch the x-axis. That's what happens at these points right there. They create a hole there. All right, number 16. All right, I think we'll have time to do 16 and 17. We'll have to wrap up with 18 on Friday. 16's function is x squared plus x minus 12 over x squared plus 6x plus 8. So x squared plus x minus 12 over x squared plus 6x plus 8. Let's find the zeros. If I didn't have a quad function, I could solve these by factoring. They're both factorable trinomials that lead off with just an x squared, which would make it x and x for x squared. Factors of negative 12 that add to positive 1 would be a positive 4 and negative 3. Factors of the bottom, again, x and x for x squared. Factors of 8 that add to 6 will be positive 4 and positive 2. Okay, which is actually kind of a good thing to see because you can see that those factors are the same and would actually cancel each other before this was ever even graphed. Okay, which is kind of a good thing that we'll need to know on Friday when we do 18. Okay, this right here, what zeros do these create? If I set these equal to 0 and solve them, this would make a 0 of negative 4. This would make a 0 of positive 3. What about the denominator? This would make a 0 of -4, and this would make a 0 of -2. So here are the zeros. We're going to use that information, right? That's going to be very beneficial in answering all these problems. So let's see, the first thing it's going to ask me is the domain. What does the domain come from? Again, the zeros of the denominator need to be excluded from the domain, which means all the numbers on the number line except -4 and -2. So how am I going to write that? Negative infinity to -4. All the numbers between -4 and -2 are good. So -4 to -2. And then all the numbers above -2, which would be -2 to infinity. So there's your domain. Then the X-intercepts and the Y-intercepts. Let's see, X-intercepts, again, I can come over here to my zeros because the X-intercepts are the zeros of the numerator as long as they're not also a 0 of the denominator. So which one of those numbers is not an X-intercept? -4 is not an X-intercept because it's a 0 in the top and the bottom. So only 3 is an X-intercept. Now, remember, when you are typing out your X-intercepts, they're ordered pairs, right? Ordered pairs that make X-intercepts are because the Y is 0. And what's my X-intercept? 3. So it's going to cross the X-axis at 3. How do you find the Y-intercept? Well, you replace all the X's in your function with zeros and see what is left. So if I do that, I would have a 0 squared plus 0 minus 12 over 0 squared plus 6 times 0 plus 8. Well, look, if this is all 0, all I'm left with is -12. If this is all 0, all I'm left with is 8. If I reduce that, let's see, 4 goes into both of those. So we'll reduce to -3 over 2. So that is your Y-intercept. That's where it's going to cross the Y-axis. So let's see. This is my Y coordinate, -3/2. And what is my X coordinate? What did I put in for all the X's? Zeros. So there's your Y-intercept, 0, -3/2. Now let's do my asymptotes. Again, vertical asymptotes are good to see from the zeros. Zeros of your denominator that are not also zeros of your numerator. So now I know that -4 is not a vertical asymptote, only -2 is. And vertical asymptotes are always X equals whatever that 0 was. So X equals -2. And the last thing, the horizontal asymptote. Again, you'll come back to the function. Since they have equal degrees this time, they're both 2's. Since they have equal degrees, the horizontal asymptote is Y equals the leading coefficients, what fraction they make, which is 1 over 1, which is 1. Right? So Y equals 1. So let's sketch out what we know here. Let's see, what do the hash marks go by this time? 2's. So 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. -2, 4, 6, 8, 10. -2, 6, 8, 10. Let's do my asymptotes first. So let's see, vertical asymptote at x equals -2. And these are going by 2's, right? I'm trying to just match what your sheet is going to match. So -2. Horizontal asymptote at y equals 1. So if that's 2, then it's going to be right before that, right? Here's y equals 1. It's going to cross the x-axis at 3. So if these go by 2's, that's 2, that's 4. So in between them would be 3 on the x. It's going to cross the y-axis at -3/2, which is -1.5. So if that's -2, -1.5. Oh, that's not even y. My y-axis, which is this one. So if that's -2, -1.5 would be right about there. Okay, so there's some good distinguishing features. Let's see if that will narrow it down for us. Okay, let's talk about our asymptotes first. Where should the vertical asymptote be? It should be at -2, which means A is good, B is good, but look at C. Its vertical asymptote is positive, and so is B's. They're both on the positive side. So it's not C or D. Let's talk about the horizontal asymptote. Where should it be? It should be at +1. So let's look at A and B. Look where B's is. It is, there's your horizontal. Positive. Where is this horizontal? It's below the origin, right? Which means it's a negative area. So that's why it's not A. It would be B. All right, let's do this last one real quick. Actually, yeah, let's go ahead and knock it out. And then we'll do the very last one on Friday. So this last function is f of x equals x minus 4 over x plus 2. So here's my function. Let's find its zeros. Let's see, the 0 of the numerator. These aren't quad, right? They're just plain x's. So I'm only going to have 1 0 in the top and the bottom. So x minus 4 equals 0. Then solve it. So add the 4 to both sides to get x equals 4. So there's your 0 of the numerator. 0 of the denominator. X plus 2 equals 0 and solve it. Subtract 2's from both sides to get x equals -2. So -2 is the 0 of the denominator. The domain. All the numbers except the 0 of the denominator, which is -2. So all the numbers from -infinity to +infinity except -2. So -infinity to -2. And what else? And -2 to infinity. Now remember the x-intercept, again, back up here to your zeros. This time the 0 of the numerator, which is 4. And it's not also a 0 of the denominator, which means 4 is your x-intercept. So your x-intercept is at 4, 0. Your y-intercept comes from what? Replacing your x's of your function with zeros. So if I do that, I'll have 0 minus 4. over 0 plus 2. 0 minus 4 is negative 4. 0 plus 2 is 2. If I reduce that, I get negative 2. So your y-intercept is at 0, negative 2. Vertical asymptote, horizontal asymptote. So vertical asymptotes come from zeros of your denominator that are not also zeros of your numerator. So negative 2 is a good vertical asymptote, right? It's not a 0 of the numerator. So x equals negative 2. Horizontal asymptote. Look at your degrees. They are equal. What happens when you have equal degrees? That means your horizontal asymptote is y equals the leading coefficient of the top over the leading coefficient of the bottom, which is 1 over 1, which is just 1. So let's sketch this. So again, it looks like we're going by 2s. So I'm going to have these, each hash mark is going by 2s. Let's put in our asymptotes first. This first vertical asymptote is x equals negative 2. Since these go by 2s, your first vertical, your only vertical asymptote will be right here. Your horizontal asymptote is at y equals 1. So there's your horizontal. It's going to cross the y-axis at negative 2. So it's crossing the y-axis at negative 2. It's crossing the x-axis at positive 4. So if these are going by 2s, that'll be at 2, 4. So those are your distinguishing features. Let's see if that can determine what this graph is. So let's see on A, it looks like it has its asymptotes in the wrong spot. Look at the vertical asymptote on A. Looks like it's at positive, and its horizontal asymptote is at negative. B is right, but let's see why the others are wrong. Let's see. D, the horizontal asymptote is right. It's at positive 1. But look where its vertical asymptote is. It's also in the positive area. See how that vertical line is in the positive part? Now let's look at C. Look where C's horizontal asymptote is. It's down here at negative. Where should it be? The horizontal asymptote should be up here at positive. So that's why it's not C. So let's make sure B has everything we need. Its horizontal asymptote is at positive 1. Its vertical asymptote is at negative 2. It crosses the x-axis at 4. So if you look right here, that's 2, that's 4. So see how it crosses the x-axis at that point? And it crosses the y-axis at negative 1. So in between the origin and negative 2 is where it crosses the y-axis. So that's why it would be B. And then we will do the very last problem on Friday before we start the other section.